All right, good evening. Welcome back to Calc 2. So today we are going to talk about numerical integration a little bit. And there's a more advanced topic for this thing, but this is kind of the basics, okay? So let me go ahead and share my screen and we'll have a look at our problems here. So this idea here, okay, the kind of thing that we're going to be doing is we're pretty much going to be counting little rectangles that we have here, okay? So here we have a line, we have x equals 3 to x equals 5, and they say use left endpoints, use right endpoints, average them, and then use midpoints, and then we're going to check to see what's going on here. Now, for this particular problem, right, we've got 8x plus 7, you can identify that as, right, as a line. So we have y is equal to 8x plus 7. It's got a pretty steep slope. Got a pretty high intercept there. That doesn't really matter. But what we would do is we would plug in x equals 3, x equals 5, right? And then we would have our values up here. Okay, we'll just plug in 3 and 5 into the function. Plug that in, and then it says what? It says we're going to use n is equal to 4. We've got to go from 3 to 5. So 5 minus 3 divided by 4. So we have 2 over 4, which is a 1/2. I'm sorry about that. I don't know why this does this, but there we go. So what we're going to do is we're going to take little steps. We're going to step, here's my 3.5, here's my 4, here's my 4.5, and then to 5. And all we're going to do, okay, is we're just going to divide these things up into little rectangles here, okay, into little trapezoids, as it were. Okay, it's terrible. Okay, and that's all you're going to do. So you're just going to have these little trapezoids here. It says add them up from the left-hand side. So we're just going to draw a little. We're just going to draw a little bar over from the left, and we're going to get this rectangle. What is going on? Okay, we're just going to get this little rectangle here, and that's how we're going to do it. Okay, if I turn it so the button doesn't hit my finger. And then the same thing over here. So we're just going to go ahead and get this rectangle because we're going from the left, add all these up. Conversely, in part B, what we're going to do is we are going to go ahead and get it from the right and add up these areas instead. Okay, so hold on for a second here. Oh no, we don't have to hold on. We're good. Okay, so that's kind of the idea of what's going on. I'm going to go ahead and advance it to the next problem because it was a little bit, in one sense it's easier, in another sense it's harder. Okay, so for this one, right, it's e to the x plus 1, okay, but we're going from -2 to +2 with n equals 4. So we still want 4 rectangles, same as the other one, right? But in this case, right, we have our x equals 2 to x equals -2. So we have 2 minus -2 divided by 4. That's equal to 4 over 4. So that's 1. Okay. So in this case, our step size is going to be 1, right? We can say our delta x equals 1. Okay. So in this case, the width of each rectangle is 1, whereas the height is going to be e to the x plus 1. Okay. And in demonstrating both of these, I decided, well, let me pick one of them. And since I know that students in this class tend to love e to the x, I decided I would do that one to kind of give you a break. Okay, so hopefully you draw a slightly different one, but this is going to be the one I'll do. Okay, so we'll say we'll have our f of x equals e to the x plus 1, going from x equals -2 to x equals 2. All right. So what I'm going to do is I'm going to get out my handy calculator here. Okay, that's my handy calculator. Hopefully you have one that looks similar to it, but it's physical. Okay, and the first thing I'm going to do is I'm going to say, what the heck does this look like? So we're going to go to y equals, and we're going to type in second function, ln. That's my e to the x. Pick your variable, x. Okay, and your parentheses, because I don't want e to the x plus 1. I want e to the x plus 1. So we're going to type in a plus 1 here. Oops, I just want 1. All right. And then I'm just going to go ahead and graph it, see what it looks like. Okay, that looks delightful. Here's my window. So I changed the window a little bit so I could actually get a good graph for this. I should have rescaled it before. But you hit the window key. Okay, and then because it went from like 2 to -2 to +2, I changed my x-min from -2.5 to +2.5. I just padded it a little bit, half a length, half a point one way and the other way, just so I would have a good picture. Okay. My scaling, right? X scaling is equal to 1 because what did we get over here? Right, we just got 1. So if it was by 0.5, I would have put in 0.5. If it was by with a third, I'd put in 1/3 here. Okay. And again, for my y min and y max, I know that e squared. So if I put in my e to the 2 here, I know it's like 7-ish, 7.8-ish. So that's why I made my y go from 0 to 10. So I just want to kind of estimate like what's my biggest point here, what's my smallest point, and again we padded it a little bit. Okay. Now the reason why I wanted the x scaling to be 1 was because I'm going to go over here and I'm going to hit second function. See this little table here? I can barely see it. I'm sure you guys can. That one, it gives me a little table of what's going on. All right. So again, I think when I did my table setup, which good Lord, so second function, this guy, my table setup, I started at -1.5. We could have started at -2. That would have been fine. But again, my table, okay, I don't need to go with 0.5, but in the second part of the problem, you'll see why I wanted to do 0.5. So I would go a little bit, like maybe half a point narrower than I really need to be. But we'll go to our table, and it lays everything out here. You can use the buttons up and down to go back and forth. So even if you missed a little bit, it'll be okay. It's just if you miss beforehand, right? If you missed the first one, I guess I did it too. So it's just trying to make our lives easier. Okay. So let's see here. What did I do? I made a little table off to the side here because I knew I was going to have to do some arithmetic. All right. So the idea of what we're going to do here, okay. So what we're going to do off to the side here is I'm going to draw my graph. Okay, so we have our graph. Oops, let me put it over a little bit. So we're going to be down here. We have our x-axis and our y-axis. So here's -1, -2, -1. I got to go up to what, 8 or something. So here's 1, here's 2. What's my value at 2 here? So I'm just going to check this to see. By the way, it's not required that you do this. I'm just going to tell you this. If your graphs always come out like, wow, how did you get that to come out just right? Like, yeah, I'm just that good. All right. They're going to look at you like, wow, you must really know what you're doing. This must be an A student because they are careful about what they do. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 was what I would have really liked. Okay. 10. Okay. You didn't have to go up that far, but while we're there, we might as well. And my graph, right? What does my graph look like? So at the value 0, I'm at 2. Okay. When I'm at x equals 2, we're up here, we're 5, 6, 7, 8-ish. So we're just going to try to sketch this in. At 1, we are at 1, 2, 3.7, so almost 4. -1, where are we at? -1 here. Okay, it's 1.36, so here's 1.3, and then we have a little bit less. Okay, so when I'm going to graph my thing here, we've got this. Okay, pretend those all hit the dots. All right, now what we're going to do is we're going to get the left hand side. Okay, so what I have is we have our X and our Y. And the other thing I checked before we started was it said round to 2 decimal places as needed. So that's all we're going to carry is 2 decimal places. Okay, we should probably carry 3 just to make sure, but I think I can get away with 2 here. All right, so if yours is a little bit off, go with 3 and then round it to at the end. All right, so so here. Okay, so we have -2, -1, 0, 1, and 2. Let's go ahead and all right, so we have X and Y. We have -2, -1, 0, 1, and 2. And all I'm going to do is I'm just going to read the values off the graph. Okay, so here I have 1.14 to 2 decimal places, 1.14 to -1. We have -1.37. So is it? Yeah, 1.37. This was 2. Because e to the 0 is 1. Okay. At 1, we are at 3.72. Okay. And at 2, all right, we are at 3.8 with 8.39, it looks like. Okay, because that's kind of the easy way of doing this. Okay, so now we have to get our part A, right? Use left endpoints. All right. So what we're going to do here is we are going to go with this. Let's make this a light color. Is that light? Kind of. Okay, so what's going to happen is I need these purple rectangles. Okay. So here, we want to go up here to 2. We go wherever 1 was, and we're going to be doing that. Okay, so the area we're calculating is this. Clearly, it is going to be off. Okay, but we already have these y values, right? We have under the purple, there, and there. We got 1, 2, 3, 4 numbers to add up. That's exactly what we're looking for. So these rectangles, right? The area is just the width times the length times the height. I'll go back to blue so you guys can see it. Okay. Width times the height or the length times the length. What is each one of the widths? Right? These are all unit 1. Sometimes they're going to be unit half. Sometimes they could be unit 1/4. Okay. They could be any particular size of the delta x here. Okay. We calculated the delta x up here. We took the difference. We took the biggest number and the smallest number, subtracted them, and divided by the number of rectangles they wanted us to deal with. Right? They said n equals 4. We're dealing with that. So that's how I got my delta x equal to 1. It's slightly different notation than your book uses. Okay, but there we are. So in each case, my width is 1. So we're going to have 1.14 times 1. Okay, we're going to have 1.37 times 1, 2 times 1, and 3.72 times 1. You don't need to write this in, but if you really want to find out, like, oh, it's an area, you can put the times 1 in because that might remind you that it's a rectangle and not we're just adding some things up. Okay. Again, if your width isn't 1, it's a 1/2, you're going to need the times the width in here. But these were all the same. So all we can do is just add those up, and that's going to be just fine. So let's quit out of this. Okay. So all we're going to get is 1.14 plus 1.37 plus 2 plus, what is that, 3.72. Okay. So our average, our integral here, right, is going to be 8.23. All right. Now, that's our left-hand side, okay? Use left endpoints. We can type that in. Okay, I wonder if they will allow me to use 2 decimal places. Otherwise, I would say use 3, but this is 8.23. Okay, 8.23, and let's cross the fingers and hope. Otherwise, we're just going to keep going. Yeah, okay, that's great. Okay, use 3 decimal places and round to 2. All right, that's how you're going to deal with that. All right, we're not going to deal with it. Okay, use right-handed. All right, so when I use right-handed, let me get a different color. Okay. So when I use right-handed, we want this rectangle and this rectangle, this rectangle, and this rectangle. Okay, so this time we're going to get the pink rectangles rather than the purple rectangles. All right, so when I'm looking at this, we have the pink rectangle starts at a height of 1.37. Okay, and then the next one is going to have a height of 2. Okay, the next one is going to have a height of 3.72, and the one after that is going to have a height of 8.39. Okay, so we're going to go ahead and add those up. Again, pick 3 decimal places for you guys because otherwise, I guess it gets mad at us. Okay, so we don't need 1.14. We need 1.37. Oops, just 37. Come on. Okay, plus 2, plus 3.72. By the way, as you're doing this with the homework, honestly, I wouldn't stress and try to get this and spend like 6 hours trying to get these numbers to work out. I just like, look, do the best you can with it. After that, just, let the numbers lie where they will, because your time is more important than trying to get a quarter point or half a point or even a point or 3 on one homework. Okay, there'll be a lot of other homeworks. Spend some time trying to get it right, unlike me, but don't stress over the fact of like, oh, it was wrong in the 3rd decimal point because it didn't round correctly. Like, just let it go. All right. You have more things to do with your time. So on the right-hand side, so this is the left. On the right-hand side, we ended up with, again, I'll go back to blue so we could read it. All right. On the right-hand side, we ended up with 15.48. Okay, this was the right. After that, they want us to average these two. Okay, so we're going to say this is 8.23 plus 15.48, all divided by 2. I'm just going to average those out. Okay, so we're going to say plus, that's going to be the last thing I put in. So we have 8.23 equals, and then divided by 2, we ended up with 88.86. So 11.86. Sorry, I meant 11, not 88. Okay, so it's 11.86. Okay, the next thing they want us to do, all right, as they say, use the left endpoints, use the right endpoints, average together, and then we're gonna use midpoints. Ugh, best of luck. All right, but that is why when I went through and I did my table, that there's midpoints in here, right? There's a 0.5 and a 1.5. Because what we're going to do now, let me draw a new sketch here. Right, this is -2, -1, 0, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You don't have to be that careful about it, but here's 2. Here's some 1. Here's a little bit less than 1. Okay. And then what were we at? We had 3 point something. Okay. And then we were up here at 5, 6, 7, 8, and some change. So we're up here. All right. So here we are with our curve. Again, pretend that connected with all the dots. when I went to Catholic school and they had to do all of this. Nuns would just be like, you're not really going to amount to much, are you? All right, so we're going to go ahead, we're going to hit our endpoints here, okay? So here's a midpoint. This is going to be at negative 1.5. This is going to be at negative 0.5. So we're here, okay? So the rectangle we want to deal with is this one. It's going to be a little bit above, a little bit below. Okay, we're going to deal with this one and this one. Okay, we're going to deal with 0.5. So we're here, and we're going to be dealing with this one and this one. Now, in the previous problem, we had what they call a linear problem, right? It was a line. So what happens is with a line, you have the same amount above and below, so they'll cancel each other out. But this is an e to the x, and this value here is much, much bigger than the value that we missed over there, okay? So this isn't going to quite work out the same way that the first problem did, because this is a nonlinear problem. And our rectangles are huge, okay? They're all by 1. They're not by half, they're by 1. So there's a significant amount of error here, okay? Like, I don't know if you've ever, well, I don't know, when you do cooking, because you're now a lab scientist, right? Like, how close do you need to get your water when you measure that in your measuring cup? Like, when I go ahead and try to count calories or anything like that, I have a scale that I weigh things on. And when I do my coffee, when I first started it, I weighed it 3 times and took the average. That's the calorie count for my coffee. That's what I put in my Fitness Pal. It's on grams. When somebody else, when I have like my niece over or something like that, and and she wants to make my coffee, she does not measure, nor is she that careful about putting a certain amount of things in. So if I have a little measuring cup that I put my half and half in, she just kind of, yeah, that's close enough. Like, it is, but it isn't the way that you would do it. So this is a significant amount of measurement error. So if you can imagine your 66-year-old daughter, your 60-year-old niece or son, or nephew is helping you with some baking, they're not very precise with it. So you might want to be more precise, but for the sake, allow the child to here, practice cooking. They're not going to be exact. They're not going to be precise. That's fine. It's not going to hurt anything. But you're going to have some error here, okay? And if the function went the other direction, right, and you were measuring from the right, there'd be a significant amount that is over. Again, it's not going to hurt anything, but in baking it anyway. But when you're in a lab, you might want to make a smaller amount here so that you don't have quite the experimental error that you normally would. Okay, so there we go. We have our x, we have our y values. So we have what? Negative 1.5, negative 0.5, 0.5, and then 1.5. Okay, that's what we're doing. So notice my table, really. Table, I went with the negatives in here because I put in my values when I did my little table setup. Where are we? We did our little table setup. I said delta table is 0.5. Okay, so we would have that table already there. Okay, so back to table. Where are we? Table. All right. So negative 1.5. We end up with 1.22. Again, go to 3 decimal places. Okay, do as I say, not as I did. I'm sorry. Okay, 1.61. Okay. It's a positive 0.5. It looks like 2.65. All right. But like I said, I would also, if you're sweating, getting a perfect grade on this, I would maybe not sweat that too much. And that is 5 points. What do we have here? 4.8. Okay, what's the base of this rectangle, right? We're going from 1.5 down to -2 up to -1. The base is still 1. Okay, the length of this rectangle is still 1. So I could multiply them here by 1, and we're just going to add those up. Okay, so in this case, we have scaling is 1, so we don't have to worry about anything. Quit out of this. So we end up with 1.22 plus 1. What was that? 64, 61, 61. Okay, plus 2.65. Okay, plus 5.8 or 5.48. Not 54, 5.48. By the way, I'm the one who grades your quizzes. If I ask you a question like this and I see this table laid out and I said rounded 2 decimal places and this is what you did, my math lab is going to mark you wrong. I will not. You followed the directions to where you could. We're not going to worry about it. Okay. So there we are. So I'll probably say something like, round all intermediate calculations. That's what these are, intermediate calculations to 2 decimal places. So we don't have to struggle with it. But that would be our answer here. And the reason why in the first one you're going to get it exact is because it's a line and it averages out perfectly. But this is a nonlinear function, so it's going to be a little different. Okay, so that's what you're doing for those. All right. So that's what those are the hardest. Actually, these two are the most tedious things that you can actually do in a sitting. I'll show you the last one when we get to it. That is not a fun problem. Okay, let's go on. Okay, that's question 2. Yeah, that's fine. I don't care. All right, a problem like this. Okay, we're supposed to use geometry to help us out. Okay, so we've got eyes like mine. We're going to go ahead and do something like this. So all we're trying to do here, right, is we're just breaking it up into a quarter circle and a rectangle, and we're just adding those up. Okay, I'm going to do one that's a little bit harder for us, but there we go. All right, this is the one I'm going to do for us. Okay, so all they want you to do is use geometry to get the areas rather than calculus. Besides, you don't have a calculus formula to get this one. Okay, this would be, you have to take engineering cap 2 to have a technique to do this one. Okay, there's no du you could have, right? Your u would be this thing, 64 minus, so if we try it, okay. So this is square root 64 minus x squared dx. If you try this, let u equals 64 minus x squared. Du is equal to 2x. Do you have a 2x outside anywhere? No. So no matter what you pick for your u, this ain't going to quite work. All right. So again, later on, there is an engineering calculus formula or technique you can employ here, but triangular integration. But you're not getting to that, so we're not going to worry about it. We're just going to make a picture, and we're going to say, well, how about we try y equals 64 minus x squared? Okay, square root. How do we get rid of the square root? Well, we square stuff. So this is y squared is equal to 64 minus x squared. And what I'd like to do now is add x squared to both sides. So we have x squared plus y squared, dang it, I'm sorry, equals 64. Does this look like a formula we've seen before? Okay, you might say, no, I don't remember that. But you do, you have seen it before because this is a circle, right? It's a circle, radius is at 0, right? Center is at 0 rather. Radius is, that's r squared equals 64. So r is equal to 8. So it's a circle of radius 8. So we'll go ahead and draw this thing. Here's 4, -8, 4, -8. So if we set, right, x equal to be 8 here, right, we get 64 minus 64, we get y equals 0. So we have a circle, we have a quarter circle. okay, because it's going from -8 to 0. So we have a quarter of a circle with radius equals 8. R squared is equal to 64. Why'd you write that down? What's the area of a circle? It's pi r squared, right? And I want 1/4 of this circle. So we have 1/4 pi times 64, okay, which is going to be quarter of 64. I think that's 32. No, it's 16 pi. So our answer here would be 16 pi. We can plug it into here. Okay, 16 pi, right? And that's what they want you to do. All right, yay. All right, so that's the kind of thing you do with this one. Okay, the same thing you do with the other one too. You just add, subtract, rectangles and wrong one. Rectangles and circles. This one, okay, find the exact value of an integral using formulas from geometry. Okay, so again, let's draw a picture. Okay, I always like pictures. If you're ever stuck on a problem, draw me a picture. Try to figure out like what they're talking about and draw that. Always happy with the picture. Okay, so we have the line, right? 2 plus 2x. That's what we're dealing with. Okay, because we're gonna solve this with geometry, not with calculus. If I solve it with both. All right. And what we're going to do is let's graph the line. Right? Where are we going from? 2 to 5? 1, 2. That's a terrible one. 3, 4, 5. So what's the distance here? That's 3. Okay, so 3 from 2 to 5. Now, if I plug in 2, right, we're going to have 2 plus 2 times 2. So that's 4, that's 6. Okay. 2, 3, 4, 5, 6. Okay, and then at 5, because we're integrating from 2 to 5. So we have 2 plus 2 times 5, which is 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what we have here is we have a trapezoid. Okay, so I ask you, do you remember the formula for a trapezoid? Of course you do. It's the first side plus the second side divided by 2 times the length. This guy. Okay. So it's going to be this one times plus that one divided by 2. So we're going to effectively get an average value here. So we're really just making a rectangle. Okay. So what do we have? We have 6 plus 12 divided by 2. Okay, times the length, that would be 3. Okay, if I ask you one like this, I'm going to be inclined to give you the area of a trapezoid. I won't give you the area of a circle. You should know that, but I am likely to give you the area of a trapezoid. So this is going to be 18 divided by 2 times 3. So that's going to be 9 times 3 is 27. And that's what they want you to do. I wonder if they want us to do it with real calculus as well. This is a pretty easy one. No, they didn't care. Check. Okay, let's integrate 2 to 5 of 2 plus 2x dx. All right. I think this one we don't need a u substitution. We could get one, but let's not bother. So this is just going to be 2x plus 2x squared divided by 2. We don't need a plus c because we have a definite integral. Okay, so we're going to have 2x, the 2's cancel, plus x squared from 5 to 2. So what we're going to have here, 2 times 5 plus 5 squared minus 2 times 2 plus 2 squared. So let's see here, we have 10 plus 25, that's 35, minus, we have 4 plus 4, that's going to be 8, 35 minus 8, it's 27, 7, yeah, that's 5 there. So we got the same thing, we're happy, everybody's good. So that's what you have to do with these. All right. Last problem I'm going to show you. Okay, it's the last problem in this section. Why is that? Because it's going to be long. I remember doing this in physics labs. I remember doing this in lots of other places. You know, as a freshman and doing lab sciences, dealing with this, it's like calculate the energy. And we'd have this little printout on a graph. We'd look at the TA, we said, do you want us to count all the boxes? It's like, well, that's one way. No, I don't want to do this. That's what they're going to have you do, though. They're going to have you draw little rectangles here, right? Estimate the city. This is terrible. I'm sorry. Estimate the city's daily usage for one way, and then average the right endpoints. So we're going to left and right endpoints, and that's how we're going to do this. So I might print this out, all right, so we can count all the boxes. I would probably go ahead and multiply the area here under a certain line, and then deal with the rest of this as I went. Okay, so we'd only be dealing with adding up the stuff that was above this line. Okay, maybe if I found a nice one, I might even draw another box here on top of the line to be able to add up that rectangle, you know, this group of rectangles here. Okay, so as many math books would like to say, the remainder of the exercise is, or the remainder of this example is left as an exercise for the reader. Good luck. Okay. So that's what you're going to do, is you're going to add up all of these rectangles. All right. In the next section, there'll be a slightly nicer way to do this. Okay, which is really what you want to do. I don't know why they want to show you this to torture you, but they do. Okay. So I would, yeah, I might print that out like this. Print it out and just start coloring rectangles. Print it out twice so you can get the left and the right sides here, and see if you can do that. One of the best advices, you guys don't have photocopiers so much anymore, you don't use them. But when I had to do stuff like this, I sit there with like sitting there with our pens or a pair of tweezers trying to get this. I remember my teacher looking at us like, what are you doing? It's like, all right, what do you do? He's like, you know, you could blow this up. Oh, yeah, I guess you could. So you just blew it up to like a whole sheet and counted the blocks that way, and it was a lot easier to deal with it. Okay, I had a lab partner, so we both did it. I think I did the left, she did the right, and we just averaged the two of them and said that's good enough. All right, so team up if you can with this, okay, and you know, see if you're getting the good answers for it. Again, if it doesn't come out to be quite right with the kilowatts, I wouldn't. I mean, I might spend 20 minutes on this homework problem, maybe 30 minutes counting up all these little boxes. But if I didn't get it quite right, it's like, you know, look, that's, you can have the point. All right, you can go on with my life. So sorry, that's how I would do it. All right, good luck, and I hope this doesn't cause you too much frustration. It would may, but there we go. All right, we'll be back in the next video to do some homework, and I will see you then. All right, thank you.